velocity of the upper plate, so which is V2. Okay, so V2. So how to determine the V2? You need to use the Newton's law equations. Okay. Newton's law equations is tau yx is equal to negative mu dvx over dy. Okay, so rearrange these equations. Tau yx dy is equal to negative mu dvx. So you need to integrate it because we have the boundary condition. So our first initial conditions is at this point, right? At the V1 is a 0.1 intersecond. At this final stage, we have V2 here at the upper. So that you need to include the condition. So here you integrate it from the distance 0 to the y distance, and this one is from the at the 0 distance, the velocity is a V1. So at the y here means that the upper plate lah. So this is the upper plate. So the distance is a y with the velocity V2. Therefore, so our range is from V1 to V2. Okay, so you integrate, it become, this is y minus 0 and negative mu V2 minus V1. Okay, so rearrange this equation. Finally, we get, so our target is V2, right? The upper plate. So V2 is equal to V1 minus tau yx y minus 0 is y lah. Y divide with the mu. Okay, then substitute all the value given. So V1 is 0.1 minus tau, which is you calculate in the question 1. So it's 1. The distance is how many? It's a 4 mm, right? 4 mm. So change to the meter. So 4 times 10 to the power negative 3 meter. So divide with the viscosity. Viscosity given. What is the value of viscosity? It's a 0.001. Okay. So divide here 0.001. So finally you get negative 3.9 meter per second. Okay. So negative here means the direction is in the x negative. Yeah. It's negative. Negative x. Here is the positive x. Okay. And then see the velocity gradient. Okay, how to determine the velocity gradient? So that we have dvx over dy or equal to delta v over delta y. Okay, so the velocity gradient is that v2 minus v1 divided with the y2 minus y1. Okay, so substitute of the value over here. Negative 3.9 minus 0.1 divided with the y2. Y2 is 4 times 10 to the power negative 3 minus 0. So that you get negative 4 divided with the 4 times 10 to the power negative 3. So you get negative 1,000 over second. Okay. So negative here means that the decrease in viscosity causes a slipper velocity gradient because the slope is in a negative. This is x, this is y, that is negative. Okay, it keep decreasing. Okay, any question, class? So far for the question 1. Any question? Okay. If no, then we proceed to question number 2. Okay, question number 2. There are 2 plates some distance apart. Means that you have upper plate and then you have lower plate, right? So between these 2 plates, water use is at 24 24 degrees Celsius. So between water at 24 degrees Celsius. The lower plate being pulled at a constant velocity at 0.4 meters second faster relative to the top of plate. Means that relative here 0.4 faster relative to the top plate means that the delta V is equal to 0.4 meter per second. Okay, so how far apart should the two plates be placed so that the shear stress tau is a 0.3 Newton per meter squared? So this is the first question, how far apart? How far apart means that this question require you to determine the delta Y, the distance. Okay, and then second, calculate the shear rate. Okay, so how to solve this question? So first you need to extract all the information given. So the relative velocity, you have delta V is 0.4, and then viscosity of the water at 24 degrees Celsius. This one you need to determine from the thermodynamic. At 24, different materials have different viscosity. Even materials at different temperature also will have different viscosity. Okay. So this information, the fluid is water and the temperature is 24 degrees Celsius. So from the table, we'll get the viscosity, which is 0.9142 centipoise. So centipoise, you can change to the SI unit as a kilogram per meter squared. This is 0.9142 times 10 to the power -3. Okay. Then similar, we use the Newton's law of viscosity to determine distance between the two plates. Okay, so that this is the initial, and then you simplify, it becomes this one lah. Tau yx is equal to mu delta v x over delta y. So substitute all the value, which is our target is to determine the delta y. Okay, so rearrange this equation. So you substitute all the value given, which is this is the viscosity, this is the velocity differences, and then 0.3 is the tau yx. So the delta y is equal to 0.122 centimeter. Okay. And then the shear rate, how to determine the shear rate? Shear rate is equal to delta Vx over delta y. Differences of the velocity divide with the differences of the distance. So delta Vx is 0.4 divide with the delta y. So this is in a meter, in a unit of meter. So you will get shear rate 327.8 over second. Okay. Okay, class. Any questions regarding the question number 2? Sebarang soalan? Tak ada. Nur Aswani, do you understood? Aswani? Okay. Muhammad Nazmi? Okay. Any question, Nazmi?
No.
No. Okay. Siti Fatimah? Siti Fatimah Muhammad. Okay. Mana Siti Fatimah ni? Tak ada. Nurul Nadira?
Yes, doctor.
Okay. The question 2, do you have any question?
No, no yet.
No. Okay, so if no, then we proceed to the question number 3. Okay, question number 3 is quite similar to the question number 2. Okay, so the distance between the two parallel plates is a 0.00914 meter. So means that this is the distance, the delta y. In the lower plate is pulled at a constant velocity 0.366 meter per second faster relative to the top plate. So this one is delta what? Delta apa? 0.366 here. Ahmad Hairul. Delta V. Okay, very good. This is delta V. Okay, so the fluid filled between the plates is glycerol at 293 Kelvin, having viscosity 1.069 kilogram per meter second. This is viscosity. So determine the shear stress and the shear rate. So this is the first one, the second one. Okay, similar we use the Newton's equations. So you extract first all the information given. Then, so tau, the shear stress means that the tau lah, tau yx. Okay, shear rate is the differences of the velocity divided by the distance. Okay, so tau yx is equal to mu delta vx over delta vy. Therefore, you substitute the value of viscosity and then the differences of the velocity 0.366 divided with the distance, difference of distance. So finally, we will get the shear stress as 42.8 Newton per meter squared. Okay, and what about the shear rate? So shear rate delta Vx divided with the delta y. So it get 40.04 over second. Okay. Okay, kelas. Boleh faham?
Faham, Doktor.
Faham.
Faham, Doktor.
Okay, any question? Sebarang soalan? Tak ada? Kalau tak ada, saya tanya. Okay, Akasha. Mana Akasha? Okay, Akasha. Okay, Akasha, how this from the initial equations, which is tau ys equal to negative mu dvx over dy, it become positive here. Kenapa? This is our basic equation, right? And then why it can become from negative to the positive? What is the value of velocity gradient? Is it positive or negative? It's positive, it become negative. This one is negative. So how it become positive? Your answer is a very near actually, because the differences, the velocity gradient is a negative. That's why it become positive. Okay, this is negative, right? So because the velocity gradient is negative, then it become positive. Kenapa? Pasal dia negatif ni. Kenapa jadi positif kat sini? Because we go back to our first initial here. Okay, so for this topic, you need to understand our first equation here, and then how to integrate, and then you need to know the boundary condition. Finally, you can get this one. Tak kisahlah positive ke negative. Finally, yang the important one, you know to how to integrate, and you choose the correct condition, then you get the correct equations. Okay. Okay, so any question before we dismiss? Any questions?
Doktor, kalau gradient shear tu positif, dia negatif.
Yes, become. Kalau the negative from here. For me, the important one is this one, the range. Let's say it's positive or negative, but you include the value, the range of the value is correct, then it will give you the right answer. The negative here is because our slope. slope is negative. But because of the range is negative here, so they become positive. Macam ni, Wak. Kat sini. Okay, for example, this one. So tadi distance, our distance is from 0 to delta y. So at 0, the velocity is a 0.4. And the V2 is a 0. So let's say we integrate it. So it's tau yx become is a y. This is y2 minus delta y minus 0. So equal to negative mu from here, negative mu. So we integrate 0 minus 0.4, right? So it becomes this one 0, becomes positive. This one tau yx is a delta y. So kalau you rearrange delta 0.4 is delta v. Y. Okay, that's why it's positive. Let's say, okay, kenapa pula ni kosong? Kita yang letak because our tadi the question said the differences is 0.4. You boleh letak, okay, V1, V2, V2 0, V1 0.4. You also can set that V2, for example, V2 0.4, then V1 is 0.8. If the V2 is 0.8, so this one is 1.2. As long as the differences, delta V here is 0.4. Okay, so that if you want to prove this one, you can try at your home. So you masukkan range dia berbeza-beza. As long as the delta V itu 0.4, then okay. So you akan dapat dia akan dapat a similar answer. Okay. Okay, any more questions? Ada soalan lagi? Tak ada? So far from me, no question. Okay, so if there is no question, so we can dismiss. So inshallah, we will see you next week. So next week, week 4, we will study on the topic of shell momentum balance. Okay, right? If I'm not mistaken. So please do our homework first before you enter my lecture class. Okay? Okay, see you next week, inshallah. Okay, take care, class. Assalamualaikum.